Only 4 light-years away from our own solar system, Proxima B is one of the planets in the system that has been sending out some really unusual signals. These signals have been deciphered by astronomers, and the brightest minds in the field of space are racking their brains to determine what these peculiar phenomena are and whether or not they indicate the presence of sentient beings elsewhere in the universe. The unusual phenomena have been dubbed artificial lights. The concept has a grain of truth to it. Near the end of 2020, it was found that our nearest neighboring star, Proxima Centauri, commonly known as BLC-1, was broadcasting a signal. Researchers suggested that we should look into the planets near Centaurus to see if there is evidence of civilization on those worlds. Even though we are still investigating the signal to make sure it is not just an echo of our own civilization, this holds true, and further analysis of the signal is being conducted. Unfortunately, the current generation of telescopes cannot pick up the faint light emitted into space by Earth's night side because the illumination is so meager. Planet Proxima Centauri b, which lies in the habitable zone and circles the nearest star, may have artificial lights detectable by our technology if they are advanced or bright enough. Even if this is not the case, there is still a possibility that we will be able to identify man-made illuminations on Earth. Whether or not non-human civilizations will be able to view the lights on Proxima Centauri b will be one of the concerns explored in our recent study that looked at the detectability of technological signatures at Alpha Centauri. The new research also suggests launching the multi-wavelength space-based observatory LaVoise in 2035. LaVoise, also known as the Huge UV Optical IR Surveyor, has the potential to do spectral surveys of the cosmos. Evidence of cultural items left behind on the planets chosen by an advanced civilization could reveal its existence. The presence or absence of technologically advanced civilizations on a planet can be determined in a number of distinct ways. For example, we could be able to see the light of a distant world jiggle with the help of a vast constellation of satellites, like the ones you're familiar with. Light from stars and other heavenly bodies is completely unique. Eliza Tabor and A. Loeb, 2 researchers, did an online test drive to look for alien lights a year ago. Since the virtual JWST, James Webb Space Telescope, isn't completely operational at this time, the results were not particularly reliable. One complete revolution around Proxima Centauri takes about 11.2 days, or about 5% of the distance that Earth travels around the Sun. Its mass is 1.6 times that of Earth, while its diameter is 1.3 times that of our own planet. 100% would imply that the night side of Earth is as brilliant as the day side, which is not the case. While 0% would imply that the night side of Earth is utterly dark. This is because the amount of artificial illumination is just slightly greater than the amount of sunlight reflected off Earth's day side. According to Tabor and Loeb's calculations, the amount of sunlight reflected from Earth's day side is roughly similar to the amount of artificial light. If the artificial night side illumination of Proxima B reaches 5%, Webb will have an 85% chance of detecting the artificial light. If it reaches 9%, Webb will have a 95% chance of recognizing artificial light. The 5% increase in brightness doesn't seem like much, but even though our Sun is only a tiny fraction as luminous as the brightest stars in the galaxy, its light is still noticeable when compared to the darkness of interstellar space. The amount of light from our Sun is still quite large, despite the fact that it is only around 20 times as brilliant as the star Proxima Centauri. If there were another advanced civilization out there, it would be hard to find it online until its lights were at least 500 times brighter than ours. You can't call this an impossible turn of events by any stretch of the imagination. Since Proxima B orbits so near to its host star, it is possible that the planet is tidally locked, with one side of the planet always facing the star and the other side in eternal darkness. This would make one side of the planet permanently illuminated while the other remained in darkness. A culture that evolved on a tidally locked planet is probably going to put a lot of thought into its lighting system. If this advanced culture used very reflective orbital mirrors to shine sunlight onto the planet's dark side, our telescopes would be able to see it. This civilization has the potential to create such technologies. However, this is currently just speculation. This study, which was released only a few days after the researchers reported their findings, illustrates that future telescopes like LaVoise or the enormous UV optical infrared surveyor might identify a civilization's light even more swiftly than the James Webb Space Telescope. To further comprehend how these telescopes may identify city lights on Proxima B and other world-circling stars up to 30 parsecs away, Thomas Batty of the University of Tucson's Department of Astronomy analyzed both LAVOIS and HABEX, which stands for the Habitable Exoplanet Observatory. The average proton cloud has a length of around 3.26 light-years. In 2035, when these probes begin cataloging and directly photographing exoplanets, neither the LAVOIS nor the HABEX probes would have yet embarked on their missions to begin exploring the cosmos on several different star systems. Batty used the LAVOIS and HABEX virtual observatories to examine known planets like Proxima B and potential Earth-like worlds around G, K, and M-class stars which could be found in some of these star systems. In addition to calculating how far away cities were from one another, Batty also calculated what proportion of the planet's surface was actually covered by urban areas. The night side of a planet will appear brighter when there is a higher concentration of urbanization on the planet's surface. This model replicates the artificial illumination given by high-pressure sodium streetlights, the most common type of lighting found on the streets of our home planet. These official lights reflect off of concrete surfaces and have an infrared spectrum that is distinct from that of the night sky. Perhaps we could have a clearer picture of an ancient culture if we had a higher rate of urbanization, say 100%. Conversely, what does it entail for urbanization to cover the entire planet? You are looking at an example of a type of planet called a humanopolis, which consists of a single metropolis covering the entire planet. No use of modern tools in the style of classic science fiction. It's not simply a fantastical idea. A future technology-evolved civilization might be able to encase the Earth in an endless metropolis. The question that needs to be answered is whether or not future observatories will be able to spot that world once it has been modeled and located. For now, finding Proxima B is most important because research indicates that urban worlds are most likely to be orbiting close by red dwarf stars. Her findings will make it much easier for future telescopes to locate a city like Humanopolis, the Proxima B equivalent. This is due to the fact that her findings show that red dwarf stars in close proximity offer the highest chance. To put this in perspective, even though we are only able to detect 0.5% of global urbanization, this is still 10 times more urbanization than there is on Earth at present. Nonetheless, the world is only 0.5% away from meeting the barrier if we look at current city development rate. The search for extraterrestrial life is deeply tied to the advancement of technology, especially in the field of astronomy. With new telescopes and instruments being developed, scientists are now better equipped to detect signs of alien civilizations. These advancements give us a glimmer of hope that, someday, we might be able to answer one of humanity's oldest questions. Are we alone in the universe? One of the most significant challenges in this search is the vastness of space. Even with the most powerful telescopes, scanning the entire universe for signs of life is a monumental task. To address this, researchers are focusing on specific regions of space where the probability of finding life is higher. For instance, the search for exoplanets in the habitable zone, regions around stars where liquid water can exist, is one of the primary objectives in the study of astrobiology. These exoplanets may not only support life, but they may also harbor technological civilizations. In the last 2 decades, thousands of exoplanets have been discovered, and many of them lie in the so-called Goldilocks zone, where the temperature is just right for life to thrive. Among these, Proxima B stands out as a particularly intriguing candidate. As the closest known exoplanet to our solar system, it lies within the habitable zone of Proxima Centauri, a red dwarf star. The prospect of life or advanced civilizations on Proxima B has sparked considerable scientific interest, not only because of its proximity to Earth, but also because of the potential it holds for answering profound questions about the nature of life in the universe. Further research on Proxima B, as well as other nearby exoplanets, is crucial for understanding whether these planets could support life or even host civilizations. For example, researchers are looking for biosignatures, gases or other chemical indicators that might suggest the presence of life. Some scientists are also considering the possibility of technosignatures, such as artificial lights or other forms of electromagnetic radiation, that could indicate the presence of an advanced civilization. These signals may be faint and hard to detect, but new telescopes, like the James Webb Space Telescope, are designed to capture even the smallest signs of extraterrestrial activity. As these telescopes come online, The hope is that they will provide the data needed to either confirm or dismiss the possibility of advanced civilizations existing beyond Earth. In addition to telescopic observations, the study of space also involves theoretical models that help guide the search for alien life. One such model is the Fermi paradox, which questions why, given the vast number of potentially habitable planets in the galaxy, we have not yet encountered any signs of intelligent extraterrestrial life. Some researchers suggest that advanced civilizations may be rare, while others propose that they might be deliberately avoiding contact with us, either because they are aware of the dangers of revealing themselves or because they are simply indifferent to our existence. Other explanations for the Fermi paradox include the idea that extraterrestrial civilizations are too far away for us to detect, or that their signals are too different from what we expect. Another key consideration in the search for extraterrestrial intelligence, SETI, is the concept of the Kardashev scale. This scale measures the technological advancement of a civilization based on its energy consumption. A Type 1 civilization, which we have not yet achieved, can harness the energy of its home planet. A Type 2 civilization can control the energy of its star, and a Type 3 civilization can manipulate the energy of an entire galaxy. The search for technosignatures, artificial signals that indicate the presence of such civilizations, is an ongoing effort. Currently, our detection methods are limited to signals that are within our technological reach, but as our capabilities improve, the possibility of discovering more advanced civilizations becomes more plausible. The search for extraterrestrial intelligence also raises questions about the nature of life itself. While scientists primarily focus on carbon-based life, as it is the only type of life we know, some researchers speculate that alien life could be based on entirely different chemical foundations. Silicon-based life, for example, has been proposed as an alternative to carbon-based life. This idea stems from the fact that silicon, like carbon, can form complex molecules that could, in theory, support life. However, silicon is less versatile than carbon in terms of the variety and complexity of compounds it can form, which makes it less likely to support life as we know it. Despite the challenges and uncertainties, the search for extraterrestrial life remains one of the most exciting frontiers in modern science. As technology continues to advance, we may soon be able to answer questions that have fascinated humanity for centuries. Could there be life elsewhere in the universe? Are we truly alone? Or is our planet just one small piece of a much larger cosmic puzzle? The study of exoplanets and the search for alien civilizations also has broader implications for our understanding of our own planet and its future. By studying the conditions necessary for life to thrive on other planets, we can gain valuable insights into the factors that make Earth habitable. For example, researchers are studying the atmospheres of exoplanets to better understand how Earth's atmosphere evolved and what might happen if it were to change. These studies could provide important lessons for addressing challenges such as climate change and resource depletion on Earth. As humanity prepares for the future, exploring the stars and searching for life beyond our solar system could help us prepare for the challenges of the coming centuries. Advancing our knowledge of space will not only satisfy our curiosity but could also hold the key to our survival as a species. By understanding how other planets support life and what conditions are necessary for a thriving civilization, we can better appreciate the delicate balance that sustains life on Earth and the need to protect our environment. In the future, space exploration could become more than just an academic pursuit. With the development of new space technologies, it may be possible to visit and even colonize exoplanets. Companies like SpaceX and Blue Origin are already working on technologies that could enable humans to travel to Mars and beyond. While the idea of colonizing another planet might seem like science fiction today, it could become a reality within the next few decades. If humanity is able to establish a permanent presence on another world, it would mark a monumental achievement in our exploration of the cosmos and our understanding of life beyond Earth. In the coming years, the focus on finding alien life will likely continue to drive advancements in both space exploration and technology. New telescopes like the upcoming Roman Space Telescope will join the search for exoplanets and technosignatures. As our ability to detect distant planets and civilizations improves, the likelihood of discovering evidence of alien life will grow.